So what's the measure of arc AB?
65.
Does it look like 65? Maybe, well,
Oh, I was just reading.
well, let's talk about this more. If I have a circle and I have a central angle that is 55 degrees, then this arc is 55 degrees also, from there to there. Okay? If I have, instead of being a central angle, let's make it be that kind of an angle. In other words, an angle formed by two chords that intersects on the circumference of the circle, then whatever that angle is, this is twice that. And the only thing you really have to remember is either that arc is the same as the central angle, or it's twice the angle that subtends that arc from the circumference. In other words, I would say angle theta subtends the arc from A to B, like that. Now,
So is the...
let's take the situation we're looking at here, which is slightly more complicated. And that is, we only have one chord and a tangent line. And we know this angle is 65 degrees. What is this arc from B to A measured this way?
How do we know it's that arc instead of the other one?
Good question. I think if it's not specified, you always do the shortest one. Always do the one that's less than 180 degrees. But if there was a third letter, in other words, notice that in question 4, you would never have that question, because DF would definitely be this arc here. Whereas if I wanted to measure DF going the other way, I would call it DEF. So as long as you have 3 points, you can always distinguish between the two. The only time you have a problem is when you only have 2 points. And then when they say the measurement of AB, they mean the short AB. So notice that this is very similar to the first problem I drew. In fact, let me draw it this way. And instead of a tangent line, I'm going to put a line like that. Okay? If that was 65 degrees, what would this measurement be from there to there? There's
120.
situation.
130.
Right. In other words, it's either double or it's the same. And it's the same only for central angles. Okay? So when I change this to making the bottom line a tangent line, it's basically subtending the arc from here to here, going in this direction. Right? I mean, you can kind of see that, why that would be the case.
Mm-hmm.
And that's the answer, is 130 for the measurement of arc AB. Naturally, if that's 65, this is 115. And this arc going from here to here would be 230. So even if the angle is not formed by 2 chords, but a chord and a tangent line, same rules are going to apply in terms of the arc that is subtended. Okay?
Okay.
Number 4. They want to know the measurement of DEF.
DEF. So 117 times 2, 4, 1, 224.
234.
34.
That's all right. And that's correct, 234. Okay? So it doesn't really matter. In other words, the following situation where I have two chord lines that subtend this arc from there to there. Well, if my bottom is not a chord but a tangent line like that, then clearly it's going to subtend all the way to there. And that's what you have to realize. And that's what you did here, is double that angle, even though it was not two chords, it was a chord and a tangent line. The rules are still the same. On number 5, what's the measurement of angle 1?
130.
On number 6, the chord is not drawn to scale, the diagram isn't. AB is any chord that is not a diameter of the circle. Okay, they're merely telling us that AB does not go through the center of the circle. Line M is tangent to the circle at point A. Which statement must be true of those 4 statements?
A.
Correct. Because if AB was a diameter, then it would be perpendicular to that tangent line, right? In which case X would be equal to 90 degrees. If AB was a diameter. Since they're saying it's not, it's somewhere to the right of the center, then this angle, in other words, this arc from B all the way around to A has to be less than 180, making angle X less than 90. Yeah, okay. I'm not so sure that I like their less than or equal. I don't know how it could be equal. If AB is not a diameter, then that angle has to be less than 90. All right. Number 7. Find the value of equal X. What's the rule for intersecting chords in a circle?
You add them and divide by 2.
So what's angle X?
It should be 115.
So if I add them, I get 230, divide by 2, 115, and 115 looks correct. Always do a visual check. Even though they told us up here they didn't draw it to scale, most of these things are drawn to scale. And usually when you make a mistake, you're off by a factor of 2, right? It's really easy if you make a mistake to be off by a factor of 2. So by eyeballing it, you're always going to be able to tell whether your answer is correct or not. Number 8.
Minus 180 minus 122.5
Hold on a minute. What's this angle right here? These are the two key angles right here, not the 122.5.
Well, I know, I just had to use that to find that one angle. So it was 57.5.
57.5, okay. So that's 57.5. That's also 57.5 because they're vertical angles. So how can I solve for x? Give me an equation to solve for x. 57.5 has to equal what?
X plus 45. 45? 45 divided by 2.
Okay. If we solve that, we get 115 equals x plus 45. X would be equal to 70. And again, if we do a visual check on it, 70 looks about right for that measurement there. Certainly not 90. Okay, number 9. Yeah, number 9's an interesting problem. You've got it done right there. In other words, if the angle they've pointed out is x, then the important angle, the one we're interested in, is 180 minus x, right?
Mm-hmm.
So I can say that 180 minus x has to equal 1/2 of the sum of 30 plus 2x minus 30. So it's 30 plus 2x minus 30. Now we can solve that. We get 180 minus x equals x. Add x to both sides, you get 180 equal 2x. X is 90. And again, it does look like a right angle. Okay, let's look at 10. What is true about two tangent lines that intersect outside of a circle? What does it make this angle?
It makes it 1/2 of
Does it look
the
like?
arc angle.
It would make it 123. Does it look like a 123 degree angle? No. The way the formula works is that this angle, x, is half of the sum of the two arcs. Well, this arc is 247, but then we got the inside arc that has to be 113. So it's the average of those two. Hold on a minute. That doesn't sound right either. Do you have your geometry book?
Yeah.
What's the formula for this?
It's... where did I...
It's subtracting.
Yeah, you subtract it.
Half of 247 minus 113. Well, 247 minus 113 is 134. We take half of 134, we get 67. And that does look right. So when you have two tangent lines intersecting you take the two arcs that are subtended. We have a 247 degree arc and a 113 degree arc, both of which are subtended by these two tangent lines. Subtract them, divide by 2, that gives you x. Number 11, we have a tangent line and a secant line. Same thing. Hold on a moment. Notice that those two lines subtend two different arcs. So we're going to do the same thing. We're going to subtract the smaller arc from the bigger arc, and we're going to divide that by 2, and that's going to equal 29 degrees. And x ends up being about 60, I think, 58. See, what do we get? We get 58 equals 114 minus x. So x equals 114 minus 58. X is 56 degrees. Okay, so that general rule works whenever you have two tangent lines, whenever you have a tangent line and a secant line, or in number 12 we have two secant lines. Well, two secant lines are going to do the same formula. You take whatever two arcs are subtended. So give me an equation that's going to work for number 12. I'll start you off. 34 degrees equals what?
Wait, hold on. How did you get that? 11.
Okay.
So I'm getting like negative something.
Well, okay. So we have 114. That's the big arc.
Yeah.
Minus the little arc, minus x, divided by 2 equals 29. Now when we do the algebra, I know what you did. You left the negative x on the right side. Solve that equation. You got to take the x to the other side and the 58 to the left.
Okay. So I have to add x.
Correct.
Minus 58. Okay.
And that way you'll get x equal 56. Okay. What equation can you write for number 12 using exactly the same principle with two secant lines instead of a secant and a tangent? In other words, it doesn't matter. All three of these are the same. You just have to figure out the two arcs that are subtended. So what's the equation on 12?
3x minus 2 minus x plus 6. 3x minus 2 minus x plus 6 equals 34.
Divided by 2 equals 34. Remember, it's always the difference of those two arcs divided by 2. It was that way for this problem, and this problem. Now let's solve that, because the algebra, there's a potential error you could make here. What's the first step to solve this? Equation.
Multiply by 2.
Okay.
Oh no.
Yeah, I always get rid of denominators, first thing. Now what's the next thing to get rid of?
Combine like terms.
Well, we want to get rid of the parentheses. You can't really combine like terms until you remove the parentheses. So remove both parentheses and tell me exactly what you have before you combine anything.
3x minus 2 minus x minus 6.
That minus 6 was the place that I was concerned about. In other words, that negative sign has to be distributed to the 6 also. So now we have 2x minus 8 equals 68, 2x equals 76, x equals 38. And again, I guess 38 makes sense. That means that little arc would be 44 degrees, which looks about right. Can you still hear me? I heard a beep.
Yeah.
Okay. 3:59. I have a 4 o'clock, so I'm going to have to run. But I will talk to you next time.
Okay. All right. Thank you. Bye.
Bye-bye.